So, welcome back to Tech Days Online 2017. My name is Rob Fraser. I'm Director of Technical Evangelism here at Microsoft in the UK. And in this session, we're going to be talking a little bit about the Internet of Things. The Internet of Things is a set of innovations, an area where we're seeing a lot of innovation and a lot of uptake from customers and from partners. The interesting thing about Internet of Things is that it's a wide set of disruptive set of technologies. And in some ways you can think about it as a third wave of the Internet. The first wave we kind of connected up all the computers. The second wave we connected the people into Web 2.0, the social web. The third wave we're connecting everything else. The interesting thing of this is that the Internet of Things is said by analyst companies to be about to generate maybe up to $3 trillion in new economic value. The problem with that has been that many of the use cases which we then talk about and which you'll see people describe around Internet of Things tend to be more on the trivial side, such as the internet connected fridge and the toothbrush. I'm sure there's an awful lot of value in knowing what is in your fridge and what you need to replace, but it's difficult to see how $9 trillion of new economic value can come out of these kind of scenarios. This is because the real Internet of Things is something very different, and as Kevin Ashton, who invented the term Internet of Things, describes, it's really about taking large amounts of data out of the world, which we've not been able to do before, get it to somewhere useful, like the cloud, apply intelligence to it, and make changes back in the world. And it's this scenario which is really going to drive a lot of the innovation and economic impact out of Internet of Things. Now, the way we're seeing this working is that there's obviously trends towards using wearables and fitness devices like Fitbits, for example, to sort of quantify yourself and understand more about the data which you are yourself generating, how that can be used. We also see a lot of industrial scenarios in Internet of Things, so the ability to take far richer and faster and real-time streams of data out of things like elevators, lifts, jet engines and so on, and use that to provide new levels of service, predictive maintenance, analytics over usage and failure, even new business models. So increasingly the Internet of Things allows us to think about more physical objects started becoming services which you can subscribe to. And of course we also talk about very large-scale systems of Internet of Things such as smart cities. But it's really important, I think, to understand that the ability to be creative, to create new connected experiences that can really enrich and improve people's lives is something which hasn't really been deeply explored in the IoT space, although it has been in the subculture around the maker movement. We should be embracing, with the Internet of Things, the transformative effect that these connected technologies can have on people. And it particularly resonates with our mission here at Microsoft around empowering every person on the planet to achieve more. So today we're going to be discussing this with a leader in this particular space. I'm delighted to welcome here into the studio Haiyan Zhang from Microsoft Research in Cambridge. Haiyan is a designer, a technologist and a maker of things. She's Innovation Director at Microsoft Research in Cambridge, where she and the team focus on inventing cutting-edge technology, and particularly at the moment in the area of connected play. But many of you may have seen Haiyan on the BBC documentary series Big Life Fix, and we'll be talking a little bit about that in a second. Prior to MSR, she was formerly Innovation Director at Microsoft Game Studio Lift London, and was also worked for design consultancy IDEO, where she created sort of innovative tech experiences around entertainment and in some cases financial services. But all this is informed by Haiyan's previous life around software engineering and user interface design. And she's lived and worked in Australia, Toronto, China, Italy and San Francisco, now resides in London, and was named as one of Marketing Magazine's Digital Mavericks. So Haiyan, welcome to Tech Days Online, welcome to Microsoft UK.
Oh, thanks for having me, Rob.
So wonderful to have you here. What do you do as Head of Innovation at Microsoft Research in Cambridge?
So at the moment at Microsoft Research, I'm leading a team. We're called Connected Play, and we're specifically looking at how play scenarios figure into the Internet of Things. So we're thinking about IoT on two fronts. One is about, as you discussed, collecting data and helping businesses make critical business decisions. At the other point, we're thinking about, well, how do things actually interface with technology. So in this case, we're looking at toys and gaming scenarios and trying to blend the physical and the digital so at the consumer end, they can have a delightful, meaningful experience when they're playing with their toys.
So you're very much focused then on kind of the human-computer interaction design around these connected scenarios. That's really where you're focused.
Exactly. We're also thinking about sort of big data and what is the business strategy, what's the technology strategy about collecting more information. But we're really thinking about it as, I think traditionally in the Internet of Things has really focused on Wi-Fi or Bluetooth, sort of sending data up to the cloud. And we're saying, well, what are some in-home experiences you can have with these things that are more delightful?
So you raise a really interesting point there, which is that part of what you do is also about designing a business model or a commercial model around the technology. It's not just about the connected scenario itself. And that's something you could probably criticize a lot of maybe some of the developments in IoT around, being that they're kind of technology looking for a business problem, right? So the business design aspect's a key part of what your group does?
We touch upon it. Obviously, we are all technologists. We consider ourselves makers first and foremost. But definitely thinking about strategy from a business perspective is really important, especially to try to commercialize some aspects of our work, to talk to third-party vendors, and to talk to Microsoft Business internally.
So where did your fascination, your passion around this kind of maker, designing connected experiences, where did all that come from?
I guess, I've always been, I come from a more traditional software engineering background, the waterfall model of developing software. But in the last 10 years, I've really gotten more involved in the Arduino community. I love this idea of democratizing technology so that anybody can access the tools to make new kinds of devices, especially technology devices.
Okay, so what we're going to do is we're just going to run through a couple of the things you've worked on, a few of the projects recently, and just tell some of those stories to sort of illustrate some elements of this. So let's go to something which probably couldn't be further away from the area of connected play, and that was the nuclear incident that occurred at Fukushima after an earthquake and tsunami. So tell me a little bit about what your story is there.
Right, so in 2011, after the Japanese earthquake and nuclear disaster, there was just a distinct lack of information online, trusted information about radiation readings at the center of the event at Fukushima and also across Japan. So there was a lot of panic on the ground in Japan and even in Tokyo. And one of the things that I did, just sort of using a spare few hours of my weekend, was I thought, well, how can we access this information that is actually available online, and how can we make it visually informative to people on the ground in Japan and to the rest of the world that was watching? So I found that the Japanese government actually publishes live radiation Geiger counter readings from across Japan. There was a academic network of Geiger counters. They published this in PDF format, buried on their website. And so working with other developers around the world, we were able to extract this information into XML format. And then I was able to pipe this into a maps mashup in order to visualize the information. And this is really, it was very quickly done. I tried to make the information more accessible, but also allowing the viewer to make up their own minds about whether the readings were dangerous or not, because there's a lot of politics and subjectivity around translating these kinds of radiation readings. And this really became quite useful in Japan. A lot of people actually made YouTube clips of reading this map, and also it was on Japanese news as well.
Right. So we're showing one of the maps here, actually. So this was something which was updated frequently based on latest observations from both government and individuals' own sort of Geiger readings. Right. Okay.
So that's the second part of the story, that the Japanese government had this network of Geiger counters. Now, in the aftermath, the Japanese government, had some issues with communication with communities. They were not a trusted source. by the population, and also they had a limited number of Geiger counters in this network. So as part of this, I also connected with an organization called Safecast in Japan, and their mission was to create open source Geiger counters to be distributed around Japan to local citizens so that they could make their own readings and upload those readings to our database, and then those readings would also become visualized on this map. So what was really important was not only initially the visualization, but also this citizen science movement that was about giving people the tools themselves to interrogate their environment and to contribute to the bigger cause of collecting lots of information, lots of data, so that everybody could make use of it.
So this basically became a combination of open source hardware, essentially, combined with cloud-based services and visualization, all put together under umbrella of citizen-based science to crowdsource vital information at a time of great public anxiety.
Yeah, exactly.
So how long was it from having the idea to actually having the first sort of set of services up running for people in Japan to access?
So myself, with the map itself, it only took a few hours because the tools are so readily available.
Yeah.
With the Safecast organization, I believe it took a few weeks for the whole kind of network to be up and running. And then it took maybe a month or two to get an open source design out there for the electronics. Now, this organization has been going for the last 6 years and is very dedicated, because I think when it comes to radiation readings, you really need to stand behind your product.
Yep.
The hardware is open source, but also it's calibrated and it's scientifically verified by experts in the field.
Yeah. So it's interesting, just as a scenario though, that this combination of at-scale access to cloud and cloud services around IoT, the ability to authenticate and connect up multiple cheap open source devices together with some creative secret source means that in future, if these things happen or something similar, we can have far faster citizen-based responses and complement the good work the governments do around these areas with stuff from citizens as well.
Exactly.
Fantastic. So I thought that was a really interesting story, and I think it's kind of moving on from that idea then of the citizen science and the sort of, in this case, emergency response. I thought it'd be lovely to talk about this lady here next, so Emma. So do you want to give us a little bit of background to Emma's story?
Right, so I became involved in a BBC documentary called The Big Life Fix, and we started filming last year, about 12 months ago. And so The Big Life Fix is a documentary series. We had about 9 stories in the series. Myself and 6 of the makers were involved to basically create new technologies to support someone in need. Many of the stories involved people with disability. There's one gentleman, James, who was born with a collagen deficiency, and therefore he is in he's in bandages, constant pain, in a wheelchair. He's unable to use his fingers very well, but his passion in life is to be a photographer. And so my colleague on the documentary, Jude, created an open source a 3D printed rig for his camera so that he could operate it from his wheelchair without the aid of very specific finger movements. And in this case, I worked on a few of the different stories. One of the stories that really kind of I took to heart was Emma. Emma, she's a young designer and creative director in London. She, at the age of 28, she was diagnosed with Parkinson's. Wow. It's a very rare thing to be diagnosed with Parkinson's at such an early age.
Absolutely.
But she's really taken it on as something to kind of she's become a spokesperson for Parkinson's UK. She's really integrated, I think, the condition into her I guess, her being, that she's sort of almost overcoming it through just her optimism. And in the story, in this particular story, she wanted to be able to write and draw again. And because of her early onset symptoms, she had a lot of tremors in her hand, and she was unable to control her hand well enough to be able to write and draw. So this is where I came in, and I spent a bit of time with her and created a lot of prototypes in order to see what we could do to kind of overcome those symptoms.
So the basic idea was that Emma was suffering from a lot of hand tremors. As a graphics designer, that meant that she couldn't essentially engage in her passion, which is around graphics and design. So you were trying to find some way of helping her manage, mitigate, or otherwise cope with some of the symptoms of Parkinson's are impacting on her life that way.
Yeah, exactly.
So what was the kind of process you went through in terms of trying to come up with a solution?
I did a lot of desk research, reading research papers, looking at sort of various projects in this domain. I also, spoke with, just ran a lot of brainstorms, consulting with different people. Of course, this is, it's an interesting case. It's, I think the solution was a mix between a creative solution, but also a very technical solution. I talked with a professor from Oxford about using magnets, and we created a rig with magnets that would sort of dampen her tremors. So that's kind of the process I went through. I think it was a mix between a design process and an engineering process. And my approach has always been, from a design perspective, it's really about observing Emma and also talking to experts in the field and potentially extracting some insight from those observations that might be used to think outside the box and create a solution that perhaps no one's really tried before. So that's what I tried to do. And at times, I didn't think I could come up with anything. And actually, the producer of the show later told me that out of all the stories, they actually didn't think this story would produce a solution. Thanks for telling me after the fact.
That was a nice brief for you then. So before we talk about the actual kind of solution you came up with and the impact it had, so how long, can you give everybody a view of what was the length of process here? What was the time which you were engaged with?
Right. So this was really it took about 6 months, but this is not very typical of a design engineering process in that it was very part-time. I worked on this maybe 1 day a week or 1 day every 2 weeks because of the filming schedule as well. But we had specific phases in the project where initially I spoke with Emma and spoke with experts at Parkinson's UK, medical researchers, and then there was a phase where I created a number of prototypes to get Emma to try them out. And out of those, we sort of had one that had a lot of potential. Then I built. I evolved those prototypes and I tried them out with more people with similar conditions to Emma. And then finally we had the kind of final reveal where we were able to present Emma with the solution.
So let's talk a little bit about actually what the solution was. So this is a picture of the Emma, I believe.
Right, yeah.
So can you talk us through what we're seeing here, what the device actually is and how it works?
So the device is called the Emma, and it's a device that basically emits vibrations in specific patterns and durations. Emma wears this on her wrist, and when she needs to write or draw, she turns on the device and she can customize the vibration patterns that it's creating. And the vibration patterns serve to interrupt the tremor signals happening between her brain and her hand. And it doesn't stop her tremors, but when she goes to make the action of drawing or writing, she's actually able to control her hand much better, and she's able to actually be able to perform the activity.
Yeah, I mean, if we look here, I think this is an example, of the sort of before and after view of Emma's writing, right?
Yes, exactly.
So I guess the one on the left is previously, before use of the device, and obviously the one on the right with the device. So to my untrained eye, that's a profound change.
I mean, I am, every time I see her use it, I'm really just amazed. I'm amazed.
So so the device itself, by a certain set of vibrations, is able to help Emma, I guess, through a nervous system mitigate the vibrations, the tremors through Parkinson's. How did you discover, what was the process, the design process or the experimentation process you went through to get to the point where you realised that was the solution? What was the kind of insight you needed? Was it from medical journals? Was it just from experimentation and trial and error?
Right. I mean, I think there were a few different factors, and I should mention that in all of this, I was very lucky. It was very serendipitous to come upon this solution and have it work so well. I think one aspect is just in looking at the research literature. There's been some projects related to physically constraining or dampening the tremors. So I've seen projects where there is a device that someone is wearing, and when they move their hand in a particular direction, the device might vibrate in the opposite direction to kind of basically physically constrain the hand. So I think I think from that, the idea of vibration in general in approaching Parkinson's or other movement disorders is something that is being researched into, perhaps with different motivation, with different motives, to physically constrain rather than sort of short-circuiting the signals. There have been other research that have been about kind of, let's try to kind of generally vibrate limbs to see if that has some effect. So in reading all this research, and then Emma and I visited Parkinson's UK, and what really struck me was that there is another symptom that Parkinson's researchers have, Parkinson's patients have, which is freezing gait, which is when they're walking, and suddenly they stop. They can no longer control their legs. And one of the anecdotal solutions they use is a metronome. So they'll take out a metronome and turn it on. It's a metronome used for musicians. It just makes a ticking sound. And the ticking sound helps to distract their brain from whatever process is going on in controlling the legs. And once their brain is distracted, they're able to walk again. So kind of synthesizing these different pieces of insight together, I thought, well, what if we injected into their hand a distracting signal such as vibration, and see what effect that has on her. And quite, I think, surprisingly, it dealt with her symptoms very well.
So did you have to go through an experimentation phase there where you're trying like different frequencies, different kinds of modulation? So there was a testing phase.
Exactly.
And how important do you think within this kind of creative design makerspace, how important is serendipity, that kind of element of luck, I guess, or tripping over something? Is that something which you come across a lot in the way that you work?
I would say it's very important. I think perhaps we undervalue it by saying it's serendipity, that it's in the design process we call it synthesis, which is design really an important part of design. The design process is looking at qualitative information. So I think in an engineering process there's a reliance on quantitative data, which is looking at a wide population of users or data and seeing what averages or trends come out of that kind of large data set. In design, we value qualitative data, which is being very strategic about the specific pieces of data that we access to, and then synthesizing insights from those pieces of data. So for example, this might be about talking to extreme users when you're designing a service. So if we're designing a music streaming service, for example, in the design process, we would talk to people who hate digital music. So these would be extreme ends of the bell curve, or people who are just early adopters of digital music, who are kind of running their own maybe pirate digital music stations. So in talking to the extremes, we're saying that we can tap into trends that haven't emerged in the sort of the mainstream yet, that will emerge because everybody's kind of moving towards this kind of extreme anyway. So there's a real reliance on qualitative data, and then there is a process for synthesizing that data into insights that we can then design new services from.
Very good. So, what's next with the Emma device? What's happening next?
So I've got also a day job.
I didn't like to mention that actually. Yeah.
But as part of this process, I'm talking with some researchers at UCL, and we are looking to collaborate on conducting a trial with the Emma device on Parkinson's patients, but also potentially other types of movement disorders like dystonia, essential tremors, and I think the next steps are to validate that the device works for, we can verify it works for a subset of the population, and then to look at how we can then bring that out so that people have access to it. And so I'm also talking with various charities and organisations.
And has this continued to have a strong impact on Emma's life? Has it been
yes, I believe so. I just saw her on Twitter. She was at a book signing. She's got a autobiography out, but she was signing her books with the watch. So that was great.
So that's fantastic. So I think that's a fantastic example of how some creative, design-led approach to innovation around wearable devices, in this case, leads to a sort of great outcome for individuals. I think what we're going to do now, we'll switch gears a little bit and we'll talk about another scenario. For this section, we're going to be joined by one of my colleagues from the technical evangelism team here at Microsoft, Lee Stott. This is another one of the scenarios that you were working on with the Big Life Hack. And this is around the area of, I guess, treatment of a fairly debilitating chronic illness in particularly in children with cystic fibrosis. So I know you've been partnering up with this. So Lee, would you give us a bit of an overview? What's cystic fibrosis?
Yeah, so cystic fibrosis is the most common genetic illness in the UK for children. So it's basically when there's a mutation of genes in both parents, and both parents need that mutation of gene, which then causes a 1 in 4 chance of the child being born with cystic fibrosis. So cystic fibrosis is a chronic condition of the airways and lungs. Basically what happens is mucus is created on the lungs, which then causes infection within the lungs. So the children have to go through physiotherapy to try and remove the liquid within their lungs. And that's done by various forms. So when the children are little, it's percussion, where the parents have to undertake physiotherapy. Or in older children, it's by using devices such as PEPs or acapellas, which are breathing devices, which the children use to actually then try and clear their airways. A PEP is just a medical device, like a mask, which the children breathe through. And what the children have to do is breathe in certain ways to actually, move the mucus through their airways and literally, out as phlegm. So it's very important that children do this, because infections is one of the biggest problems, and if a child gets infections, then they require IVs, they require stay in hospital, which then impacts on the school and their well-being, and potentially then results in a transplant being required. So
we think about that. So what you seem to be describing is almost like the breathing equivalent of physiotherapy on the lungs on a regular basis.
Yes. So the whole goal of what we want to try and do is encourage more children to do physiotherapy, and we know it's medically proven if children do physiotherapy well and they live active lifestyles, the chances of infections are drastically reduced. And again, what we have today is, physiotherapy is quite a burden on the parents and on the children.
Let's say, I mean, what for a family with children who are living with cystic fibrosis, what's the kind of daily regime like?
Yeah, so children with cystic fibrosis have to take lots of medicine. So they're up to 50 to 100 tablets a day. They have to take physiotherapy twice a day.
Sorry, 50 to 100 tablets a day?
50 to 100 tablets per day.
A day? So
the morning routine with any parent with cystic fibrosis is 10 to 15 tablets immediately. And then they have to eat enzymes with any food supplement. So they have to take a substance called creon, because one of the impacts of cystic fibrosis is on the pancreas. So what happens there is they can't digest fats within their diet. They have to have a high-fat diet because they're losing lots of weight. So they have to take creon to supplement that, add the enzymes and actually consume the fat. So again, children have to continually take tablets while they eat. So the more chocolate they eat, the more tablets they need to eat.
How many hours a day of breathing exercises?
So they have to do physio at least twice a day in 20-minute blocks.
Got it.
So
Okay.
it's up to 40 minutes. Ideally, if you do more, the more healthier you can keep.
And this is with kids who ideally will be preferring to do many, many other things.
Playing on their iPads, playing on their Xboxes.
Yeah.
So
Maybe even do something in the real world, right?
something in the real, and I think a lot of it is around that boredom because it's literally lying still, lying flat in different angles, and doing breathing exercises, which again sounds great for us because we're healthy. But if you imagine a child with cystic fibrosis, it's like breathing through a drinking straw. So if you get a drinking straw and try and breathe through that 24 hours a day, it's quite hard. Big
life hack. So came along. So what was the way this challenge was presented to you, Hyam, by the program?
Right. So this is the second story that I worked on for the documentary. As part of the show, I met with a family in Cornwall, the Coxheads. They have 4 kids. And 2 of the kids, Morgan and Aiden, have CF. Aiden specifically is also autistic. This is something that they've been living with since birth. They really hate doing their physio. I went out to Cornwall and I watched Morgan do his physio, and he was just really struggling with it. So my challenge was to make physio more fun, more compelling for the boys. So that's kind of how I became involved.
So the challenge wasn't necessarily it wasn't a medical innovation or a treatment innovation as such, but it was about how can the existing treatment regime be made more engaging, potentially much more, I guess, productive and better outcomes than the existing kind of let's just get on and do. Okay.
Yeah.
So what was your initial thought? So what did you think?
So I went in and my initial thought was, I met with Vicky, the mum, who was just really lovely and it was amazing. She's got these 4 kids. Every morning she gets up at 6 a.m. to go through to set up for the boys' routine, but also she needs to make sure, the other 2 kids are also getting her attention as well. So it was really amazing meeting her and seeing the challenges she's facing. And for me, it was really thinking about, well, what kind of fix would actually help her in her daily life. I think the idea of turning a physio into a video game was something that she was really keen on, because the boys, they play Xbox and they play Minecraft on their tablets. So she was very keen to kind of tap into that. And at the same time, I also wanted to expand upon just the idea of gaming itself and think about, well, how can we create something for her so that she can actually be assured that the boys are doing their physio and can kind of look back over time about the exercises they're doing.
So the core of the idea you were forming at this point with your design sort of hat on was one of creating an experience like a game which is far more engaging and fun.
Yeah.
So that would help in terms of in terms of Morgan and Aiden's physiotherapy.
Yeah.
But also thinking about how could you potentially use it as a way of mining data out of that experience to help mum and potentially practitioners and medical professionals.
Yeah. I mean, I think we had some initial thoughts. So the idea that if we're collecting this data, perhaps their doctor, perhaps their physiotherapist would want to access this data remotely.
So the data is really important in terms of physio. So children generally have to have reviews every 12 weeks, and what we find is a lot of that review is either paper-based from the parents, so it's food, diet, they literally have to document the diet of a child for a week. So what did they eat, how many times did they go to the toilet, etc. And what we thought was, from being able to have this data services, so it's much more around the data than the devices, is that impact of the child being able to really say, I did my physio and this is what I've done. And it's really the gamification of the data, not from a medical perspective, because, the idea of the game is not to be used as a medical basis, because, again, physio can't be medically evaluated, and this was a key thing that we get from all the medics, is that physio is something that you just have to do, but just because we have this data set that says a child got a score of 300, we wouldn't prescribe antibiotics off that. There's a lot more factors involved, so it's more around the gamification of how the children can get involved in physio and feel that there's some outcome to doing the physio. and again be able to compete against other children in physio.
Got it. So it's not just gamification as we might think about it in terms of taking activity such as the breathing exercises and trying to make it more kind of fun. There's also gamification over the actual outcome of that, the insights, the data.
So a real key thing with children with cystic fibrosis as well is that you can't have children with cystic fibrosis meet other children with cystic fibrosis. So it's really difficult for a child with CF to express how they feel or understand how other people feel who have got CF. So what we want to do is try and establish this method or community where children, can meet more in the online sense, whether it's, through a leaderboard or through a game, but have that level of interaction so it becomes competitive in their peer groups.
Right, so basically what you're getting towards here in your design thinking is the fact you've got essentially this idea of both connecting this in terms of the device, the data you can take off it, and how you can create kind of gamification around that experience, but also the connectivity of the kids themselves through this process to try and give them better sense of connection with other kids with CF.
Yeah.
Okay, so you had the core of this idea. So what did you actually do? What did you produce?
Well, so for the purposes of the documentary, it was really about making a one-off fix for Vicky and the boys.
Right.
Making a device that they can take home and use over a long period of time without sort of me being there, without that much tech support. And so I started out making just very simple prototypes with a kind of development board and a sensor module. So this is a pressure sensor module that basically the breathing device was an a cappella. So I kind of siphoned off some of the air coming from the a cappella into a pressure sensor. And then following on from there was to really engineer this device to be a standalone device that was wireless, that was battery powered and could be rechargeable. Thinking about how many buttons should be on this device to enable you to play a game in a meaningful way, having some light indicators on the device so that when you're breathing you can actually see the effect happening. So it was really an engineering process to take this from prototype to production to create a custom PCB. And so for the purposes of the TV show, it was really to help out Vicky and the boys. And then since the TV show, I've been chatting again with some researchers from the physiotherapy department at UCL, and working with Lee, we've set up a ongoing and a larger umbrella project in collaboration with UCL and Great Ormond Street Hospital, which is to take the engineering work as a basis and for UCL to then take this forward and create this for other families in the UK.
So I mean, the device itself is interesting. So the program was very moving. So the solution which was shown in the program was one where you're using the a cappella device with this board to enable the boys to control a character in a basic level-based playing level-based game, right?
Yeah.
So at one level, so that was how did that actually work? Was it well received by the boys? Did they find that
it was I think it's had an amazing effect. I mean, Vicky says, Morgan especially has become really engaged with the games and with his physio. I mean, previously he just thought of it as a chore. He wasn't engaged with his own medical treatment. Now they want to do it even outside of the physiotherapy hours. Aiden as well, more engaged. And we built two games. One was a standalone game that they can play on a tablet. Another one was a racing game using a physical car track.
A bit like a Scalextric.
Scalextric,
yeah, exactly. And so the two boys can actually compete to race cars. So they love kind of doing this together.
There's nothing like competition between siblings as well, right?
Exactly.
Yeah.
So the actual device then was essentially a controller for a video game. It's just it wasn't using paddles and buttons. It was using breath and the frequency and strength of breath.
Yeah, exactly.
Hence playing into physiotherapy. So that was the game control. How did you actually build the games, by the way? How were they built?
So for the games themselves, as part of the documentary, we actually staged a a hackathon where we invited about 40 people from the video game industry, students who were studying computer science or video gaming, designers as well. And at this hackathon, we challenged them with making a variety of games, and that's where the two main games came out.
Okay, so this is a hack-based engagement to try and prototype, accelerate development of games for this project.
Exactly.
And you got great engagement around those hacks. You found those willing developers in the community to do that.
Yeah, it was. I think it was an amazing process to just showcase how people are willing to donate their time and their skills to really create technologies that impact, for social good.
Okay, so we got the essentially the game controller, which is instrumentation. So what's the second part of the story then? In terms of the way in which you're then using that to take data and make that available, I guess, to Vicky and also to others. So what's the data side of this connected story?
So, with IoT, with the documentary, we've been focused on kind of what is that delightful interaction in the room. And then beyond that, collecting big data. This was really outside of the scope of what I could do in the documentary. So that's why Lee and I have paired up to work with larger institutions to basically collect data. So no, I do not believe there has been any research to definitively show that ongoing physiotherapy has a scientifically proven improvement impact on kids' lives.
So despite
anecdotal.
Yeah, so 40 to 50 years of this.
So this is the big challenge now, is we're trying to take this into a patient trial with Great Ormond Street. This is the whole focus of the event now, is to move this forward where we can have a definite proof point from a medical standpoint, that active physiotherapy. And again, a lot of the comments from the physiotherapists is they just want children doing physiotherapy, and if we can encourage more children to do physiotherapy, and then we're working with various different wearables and with these devices to see if health has a definite impact, which then can be produced as a medical report and then taken forward into a patient trial and into the CF Trust as an operational program, and that's the most important thing for us. So we've learnt lots of things from the hacks where we need to have this as a real true project. We need to define key specifications of how the games are designed, how the data is stored, and again, we've got great things now with G Cloud and N3, which is the NHS Cloud Data Service. And that's why we've partnered with institutions such as UCL and Great Ormond Street and University College London Hospitals, because they already have those data tolerances and clearances. So we're using this as a very much academic program, which drives forward real, improvements in patient care.
But you've addressed issues like the privacy and security of that data.
Exactly, because it's owned by the NHS.
Got it. Okay.
It's under the CF Trust.
So you're by doing it through the CF Trust, the Cystic Fibrosis Trust, and through a NHS Trust, you're able then to actually make sure that we've got appropriate control and access to the data, and that it's all.
And again, if we open up the games into a gaming open standard specification, it's not about open. It's an open standard with the key set of specifications, so people can have the freedom to build the games, but under a specification that will work with devices. And then if people want to start producing devices, there could be this massive open source repository of games.
So again, there seems to be a lot of parallels between this and the Fukushima story you talked a bit about, Han, because you've got essentially moved towards more open hardware specifications, and I guess in the end, open APIs, which could come part of it. So you essentially think about there may be some innovation on the device end?
Yeah, so on the device end, the key thing is that there's unlimited amounts of innovation, and this is where the program which UCL is operating is very much focused, because to have a device and a medical device is lots of CE certification and regulation, and that's something that they are experts in, and that's something they can own. And then a farmer or a medical vendor may produce or mass produce these devices, but it's more about the content, and then how that content goes into that data repository and how it is analysed by, there's three aspects to this. There's the children themselves, how good am I? There's the parents of, did you do your physio? And then there's that 12-week annual review of, did you do any physio this month?
Yeah, that's right. So the great thing about this, though, is we're talking about something that started as a life hack project from the BBC series. And then by partnering together, you've now got to the point where we're talking about an open innovation agenda around both devices and data to better engage kids in the treatment of their condition, but also make essentially the management of and potentially the outcomes for the kids better. And all of this has been something which has come out of an IOT connected device, connected design kind of thinking.
Yeah.
Right.
It really showcases the power of IoT to radically change, in this case, the medical industry, in that data that's never been collected and insights that have never been drawn about patients' lives and medical treatment can now be collected.
And I think you guys, you've got an opportunity if people are willing to contribute coming up to look at hacking again in this area, Lee?
Yeah, so we're running the Health Hack at Imperial College in London, and the whole focus of Health Hack is around taking forward those learnings from our gaming experiments and really building those specifications and standards so people can build games with Unity and other gaming tool sets, but under a standard specification, which could be great proof of concepts or great even starter projects to go back into the academic world to then say, okay, this is a standard framework, this is a specification, we want a collection of games, because again, if children have choice of the games, they'll use the devices more.
Absolutely.
Yep.
So we're almost out of time, guys, so thank you so much for coming and talking to us. Really appreciate you spending the time. I think it's interesting, this whole area of looking at innovation through design-led thinking applied to IoT. Hopefully, I think we've shown that with relatively focused activities, we can move from beyond the connected fridge and the connected toothbrush to something which is far more meaningful and far more impactful on people's lives. So thank you for telling those stories today. Really appreciate it. Lee, Hyan, thank you for coming in.
Thanks.
We're going to take a quick break now. We'll be back at 12 noon GMT, where we're going to switch gears and we're going to talk about quantum computing. So join us again at 12 noon. Thank you.